All right, today we're diving into a story that's, well, it's a little bit of everything. You've got history, you've got nature, and some truly brilliant innovation all coming together. We're heading to Kota Tinggi in Malaysia, where a whole community is fighting to save this fading light. And in doing that, they might just reignite an entire river of culture. So yeah, let's get into it. Okay, so our story really kicks off in Kota Tinggi, which is known as the historic town of Johor. And right at its heart, you've got the Sungai Johor, the Johor River. Now, this is not just some random river. We're talking about the absolute center of the Johor Sultanate way back in the 16th century. I mean, they called it the River of Culture for a reason. But today, well, its most magical residents are in some serious trouble. Yeah, we're talking about fireflies, but listen, the way this project describes them, they are so much more than just insects. They are called living artifacts. Think about that. Their synchronized glow, it's like a heartbeat for the river. It's a direct sign of how healthy the ecosystem is, and it's this hugely important part of the local spiritual and cultural identity. So to really get what's at stake here, you have to understand the three key players in this whole ecosystem. First up, you've got the river itself, the Sungai Johor, which is like the cultural artery of the place. Then you've got the star of the show, the Pteroptix tenor Firefly. This is the one famous for that incredible synchronized flashing. And finally, you have the stage, the Cineratia castellaris tree, or Barembum as it's known locally. It's where the fireflies put on their show. And here's the thing, you take away just one of those, and the whole spectacle, it just collapses. Okay, so the magic of these fireflies is just undeniable, right? But their world is incredibly fragile. And right now, it's under attack. We're not just talking about one single threat either. It's more like a cascade of interconnected problems. And, pretty much all of them are man-made. This number you're seeing, 17.8%. It's a really chilling warning. So what is it? That's the amount of mangrove area that was lost in just 15 years along a river nearby. And the result? A catastrophic decline in fireflies. So this number, it's a glimpse into the future for Kota Tinggi if something doesn't change, and fast. So this decline is being driven by four major threats. First, you've got habitat loss. Simple as that. Mangroves are being cleared for plantations and development. Then there's river erosion. Wakes from motorboats are literally knocking over those essential barambang trees. Third is light pollution. All the artificial light from cities, it completely messes up the fireflies' mating signals. And finally, chemical pollution. Pesticides and runoff are poisoning not just the fireflies, but their food too. So the big question is, how do you fight back against all of that at once? Well, the first part of the solution is this really ingenious piece of what you'd call eco-engineering. It's one of those brilliant ideas that solves a super complex problem by looking right to the natural world for the answer. And at the core of this whole solution is the hexagon. It's been called nature's super shape for a reason. I mean, just think about a honeycomb. Hexagons are incredibly strong. They're super efficient. They fit together perfectly with zero wasted space, and that creates a structure that's somehow both really strong and flexible at the same time. Okay, so here's how this hexlock system actually works. It's a three-step process, really. First, those angled faces you see, they break up and scatter wave energy, which protects the riverbank. Second, the blocks lock together, kind of like Lego bricks, actually, to form this stable but still flexible wall. And third, and this is the really clever bit, their hollow centers trap silt and sediment, which actually creates new land for mangroves to take root. So you see, it's not just a wall, it's a foundation for new life. And get this, there's a bonus. These blocks do more than just stop erosion. The hollow parts create these little mini rock pools, and those become shelters for snails and other tiny creatures. Now, why does that matter? Well, it matters a lot, because those snails are the main food source for firefly larvae. So you're not just saving the trees, you're literally rebuilding the entire food web from the bottom up. Okay, so we have this absolutely brilliant design, but the next question is, what do you build it out of? And this is where the project gets even smarter. It takes one massive environmental problem, plastic waste, and turns it into the solution for another. These blocks are made from this really innovative eco-concrete. A full 30% of the material is recycled PET plastic, the stuff from drink bottles. And that plastic is collected directly from the local community. It's a system that literally transforms pollution into a valuable building material. How cool is that? Now, you might be wondering about the strength, right? And yeah, this table shows that the compressive strength is a little lower than standard concrete. But here's the key. It's more than strong enough for what it needs to do, which is erosion control. But look at the other benefits. It's way lighter, which makes it much easier to install. And it absorbs a lot less water, meaning it's actually more durable out there in the river. And this is where the project becomes more than just an environmental thing. It's a social one too. See, they set up these community fabrication hubs, so local residents can collect plastic waste and actually sell it to the hub. Then, local workers get hired and trained to make the blocks. What this means is that the money stays right there in the community, creating green jobs and turning a pollution problem into a source of income. It's a win-win-win. All right, so the habitat is being rebuilt, which is fantastic, but how do you know for sure that the fireflies are actually coming back? This is where the project's high-tech nervous system comes into play. It's an AI monitoring platform that gives you transparent, hard proof that it's all working. So, to understand how this AI works, you need to know about something called the temporal fingerprint. It's a really fascinating concept. Basically, every different species of firefly has its own unique flash pattern. It's like its own little Morse code made of light. The AI is trained to recognize all these different fingerprints. And this really shows you the difference between the old way and the new way. I mean, the traditional method was having experts literally sit there and count flashes. It was slow, it was expensive, and it disturbed the fireflies. The new AI system, it uses 3D cameras to record the swarms and then automatically figures out which species are there with about 70 to 80% accuracy. You get a ton of data without ever bothering the insects. And what's really crucial here is that this data isn't locked away in some lab. Nope, it's fed to a public, real-time dashboard. So anyone who supports the project can log on and see the mangrove growth and firefly activity for themselves. That kind of transparency, that digital stewardship, it just builds an incredible amount of trust.
So when you step back and look at the whole thing, what you have is a project that pulls together every single thread of the problem. It's using biology to replant the forests. It's using nature-inspired engineering to protect them. It's using circular economy ideas to build the solution. And it's using artificial intelligence to watch over it all. It is a completely holistic approach to reigniting a cultural legacy.
And they have a really clear roadmap for the future, too. It's all done in phases. It kicks off with a pilot project to prove the concept, then it scales up to restore a full 10-kilometer stretch of the river. And the final phase, that's when they weave it all back into the local economy by launching these regenerative eco-tours, which, by the way, is perfectly timed for the Visit Johor year in 2026. You know, this whole project started with a simple goal: save one tiny flashing insect. But it's turned into something so much bigger. It's become this powerful model for conservation that's led by the community and backed by technology. And it really leaves us with this one big question to think about. What if saving one tiny light in just one corner of the world could end up illuminating a new, more helpful path for all of us?